Hello there, everyone. Happy Wednesday to you. Sorry, this is on a midweek night. Usually I try to do this on Friday nights because that's when I have more time. But unfortunately, my Friday nights are booked up for the next little while, just due to vacation and this. It says road rage, but it's actually a skateboard camp that I attend once a year during this time, around the beginning of August, and I go and I take some youth in a skate van, and we go down to BC, and sometimes we go to different places in Canada just to go skateboarding and have a good time. But yeah, tonight we are going to be focused on good old red and blue, red versus blue. We're going to try to get them moving on the platform that's over to my left here, over there. And we're going to try to get these guys moving around that platform, and hopefully maybe we'll get them fighting. We'll see. So the idea is to get them mounted on a platform that will be kind of like a 3D printer. It's kind of like an XY table or a CNC table, and each of these will move, in all kinds of directions. And then we have some servos that will activate these little buttons at the bottom here. When I activate the buttons, you can see that they punch. And the heads are pretty sensitive, so sometimes when you jostle them a little much, the heads pop up. But it's supposed to pop up with a punch like that. That's how it's supposed to operate. So we have this little CNC driver here. Last week we were able to figure out that we can use all four of them, and we'll need all four of them to drive these stepper motors. We have 4 stepper motors, 2 for each robot, 1 for each axis, X and Y. We're gonna have to figure out how to mount these. I guess off camera I did prepare these laptop DVD drives to hack and make work with this project. They're a little smaller than these guys, which are DVD drives and CD drives from your normal PC. Oh yeah, I guess I should turn off the sound here so we don't get any echoing. Sorry about that. So yeah, this is from a PC drive, optical drive of some sort, and we took it out, and this is from a laptop optical drive. So you can see it's smaller. The reason why we couldn't use 2 of these is because it's just way too wide, because one has to go on here like this, and one has to be mounted like that. So it's just way too wide. The nice thing about these laptop optical drives is that they fit in the width of one of these, so I think we'll have enough space. And, we're gonna fit them in this section here, and so the idea is to fit them like this and have it so that they don't hit each other. I might even mount them together in the middle. We'll see. It could work. You see, like, there's a common mounting point in the middle there. That might work out. We'll see how it goes. And then we're going to mount the servo motors to these plates. These plates will be right underneath here. They might need to be shaved down a bit because I think they're a little bit big. They might run into each other. In fact, I think they will run into each other. And we have to have enough room for them to move around without hitting the sides and that kind of thing. The height is also a tricky thing that we're going to have to deal with. So because we have these two, and this plate with the servos on it. It may be a little bit tricky to get that all working. So my idea was like I'm going to cut off all these supporting brackets. It could make it easier also for these to float around without hitting anything. So probably do that. I'll cut them off near these supports. I want these supports to still be here to provide the rigidity of this platform, but I definitely want to take those out for some more depth. So we'll do some plastic cutting today. We'll do some mounting with these guys, mounting them together. We'll do some soldering onto these stepper motors here for each of these. Get some wires on there, test them out. I'll be applying 12 volts to these motors, so we'll see how that goes. These look like motors that are supposed to be 3 or 5 volts, I'm guessing. So yeah, there's that. But yeah, maybe we'll get that going right away. Start off with the soldering and some testing and move on from there. Yeah, thanks a lot for joining, Nomad. Good to see you. And I apologize for those of you who were planning on watching yesterday. Yeah, I had a meeting that popped up and kind of stole my night. So, all right, I think I'll switch over to the soldering camera, and then we can start mounting those wires on, and then we'll do some testing with the Arduino CNC shield thing. I don't know if it has an official name. It just says CNC Shield version 3, so that's that. Okay, here we go. Let's transition. I get some wires out to solder onto these things. Make sure the wires are a decent length, because I'll keep that one. I'll use these ones because I'm not sure exactly where the board is going to be mounted. So I'm guessing it's going to be maybe mounted in one of these corners here. Let's see how it goes. That's another nice thing about cutting away these ribs, is that this board will fit a lot better. It can fit like that, but not perfect. Okay, we'll need our helping hand. Actually, you know, sometimes it's nice to keep little connectors like these. Sometimes they're handy to. They actually fit on all kinds of DuPont cables. So if you want to, you know, make, you know, your servo cables broken out and have just single connectors, you can use these little. You're gonna reuse these little guys. You just need like a little pick, pop out. Well, I guess I can just show you that. There we go. Just bend that back, and then the connector slides out, and you can reuse these guys. They're pretty handy. But I have so many of them that I think I'll just throw these away. Sorry guys, not being very green today, I guess. I also have a problem with keeping too many things around, so it's probably a good thing that I threw those away. So we'll strip these wires, tin them, and solder them to these motors. I guess for those of you that don't know, one of my passions is robotics, but another one of my passions is skateboarding. I do enjoy skateboarding. I hate to admit it, but I've been doing it for more than half my life, I guess. I think I've been doing it for about, 23 or 24 years, I think. Since '96, so I guess you can do the math on that. Trim these down a bit so they're not so long. These connections on here are pretty tiny, so don't want these wires to be too long. Yeah, if you guys have any questions about this project, definitely throw it in the chat. I'm happy to answer any questions. I'm going to get the multimeter and just double check the connections that I need to be making. When we check with the multimeter, we're looking for like 12, 14 ohms, that's close. And that's one coil, so we want to have two connections that are close together that are going to be soldered to one coil. Whoops, stapler got caught there. Dab a little solder on a solder iron and make the connections here. This is a pretty tight spot. I could unscrew some screws, make it a little easier on myself, but sometimes I like a challenge. So here we go. One connection made. Oh yeah, we got so many ads. Skip a few ads. We need some needle-nose pliers here to make some of these connections. It's pretty tight. So, anything new in robot news? I haven't heard too much lately. Although, if you follow the DF robot community at all, you'll probably be surprised to see that DF robot posted about Cynthium just recently. It's all about DJ's hack with the Latte Panda and putting Easy Builder on it. So it's pretty neat. It's kind of cool, a cool collaboration that's happening. I should definitely warm up the hot glue gun. Because we're going to need it for these wires so they don't break off. Okay, this is gonna be a little tricky. Try to make it happen. Alright, so we'll just double check, make sure we don't have any short circuits here. Put it back on our ohm setting. Hopefully you can read that. And we're looking for about 14 or 12 ohms. And that's the resistance of, or I guess I should say impedance of our coil. Perfect, 13. This is the other coil of the stepper motor. 13. Great. We are good. So we're going to hot glue that, and then we can, well, we'll just put it over here for hot gluing. We'll do the other one, and then we'll test them both at the same time. Luckily, this one is a much easier to get at. If you're wondering where DJ is at these days, he is out at his cabin in Ontario. So he's working remotely from there, and his connection speed isn't always the greatest out there, so it's pretty hard for him to do any live streams from there. So I'm holding it down back here in Calgary. Alright, we'll just use the endless pliers so I don't burn my fingers. Okay, 2 more connections and then we're good. We'll use the helping hand here. Okay, let's just test that out with our multimeter here. Make sure there's no shorts, and by shorts I mean short circuits. We just don't want to see any of these connections tied together accidentally by soldering. Okay, orange and yellow. 12 ohms, perfect. Blue and green. 12 ohms, great. That's what we're looking for. Okay, now we'll hot glue both of them and then we'll do some testing. I'll transition over here so you can see what I'm doing. Sometimes it's hard to get these things started. There we go. One thing about using hot glue on a near motor is that the hot glue could melt again, because if the temperature of the motor goes up high enough, it could remelt this stuff. But there's no other substance that's better than hot glue to, well, there might be, but to stabilize these kind of wires. You can use stuff like caprolactone, which I've seen used before, but it also melts at a temperature similar to hot glue, so you don't really get too much of an advantage. Caprolactone is it comes in white pebbles. It's usually has a few trade names, like polymorph is one of them. Polyshape, I think, is another one of them. And it comes as like little white pellets. Then you throw it into a cup of boiling or really hot water, and once the white pellets turn clear, you can then morph. Well, I guess polymorph is the name. So yeah, you can morph it. Kind of use your hands to put it, to shape it, and then I've seen it used in I think mouse and keyboard PS2 connections for the strain relief at the back of the pin headers. So that's been used, but unfortunately, yeah, it's like not a high temperature solution. It's basically the equivalent of using hot glue. Okay, so we have these two down here. I'll need to get a power supply. There we go. Need a 12 volt power adapter. We'll also need to power up the Arduino with USB. I think all I have is this 10-foot cable. It's a bit outrageous. Okay, now I don't remember. I think I have just X and Y and A activated right now. We'll have a look. So we'll plug these in first, and then we'll plug in power. I do want to test to see. I have this 7.5 supply over here. Maybe I'm going to probably use that. Do some testing to see if we can do a lower voltage than 12 volts. But the CNC shield says that the lowest it can operate is at 12. But I'm wondering if it'll go lower. I think these motor drivers, if I'm not mistaken, stop at 8 volts. So I think 8 volts is probably the lowest it can go, but we'll try with 7.5 and see how it goes. Okay, since those are plugged in, all I have to do is now add power and see what happens. Nice. It looks like I'm not getting the full range, but they are going nice and quick, which is excellent. That's what I wanted. Yeah, this one is bottoming out here, but not going the full range there. This one's bottoming out on this side, and then leaving us with about a centimeter of travel left, which is okay. I don't think we may not need the whole travel. We'll see. So excellent, yeah. The DVD drives are working. Okay, let's try a lower voltage just for fun. I think the lower voltage will also slow the speed down a little bit, which isn't great, but oh, interesting. The lower voltage is not activating this motor as it should. Doesn't seem like it has enough torque. Let's see how many amps this can provide too. It says 1 amp, so it should definitely drive those motors. We'll plug in 12 volts again and see how they go. Yep, seems like 12 volts is good. Whew! Yeah, those motors are hot. They are melting the hot glue, as I had surmised. I wonder if I could probably put heat sinks on these motors. This whole thing around it is actually heat sink. This whole metal tin part here. But we could do some further heat sinking. The only issue is it might stick out a little bit further. We'll have to see how it goes with the mounting. On the software side, we'll have to activate the Z-axis. I don't think I did that the last time on the Arduino side. So I will have to work on that. Yeah, might as well do that now while I'm thinking about it. So I'll boot up Arduino here. Just give me a moment to get this booted, and then I'll switch views so you can see the code. Pretty simple. It's just stepper driving, no sensors or anything. Okay, here we go. We'll transition over to the code. Okay, so oh yes, this is not the code that I was working with. That's for making an Arduino EZB. So let's go to our sketchbook. Actually, there's a recent. There we go, CNC. Here we go. So the Z-axis should be enabled as well. All right. Actually, so let's. I have Well, I'll just use one of these actually. Let's put this on. Oh, we should see actually. We should put them all on at the same time and see if that power supply, which is 12 volts 1 amp, can handle all these motors at the same time moving. I'm guessing probably not. I'm probably going to need a higher amperage 12 volt supply. Okay. Yeah, we'll do it like that. So the code that I used is straight off. It's an example straight off of, I think, some random website that had an example code for this CNC shield. And the only thing I changed was this value down here, which was the delay in microseconds for the step driving the stepper. This is the steps basically. It's you're driving one coil then another to make the steps happen. So it's just making a magnetic cog, if you will. So it's saying, you know, this side is energized, so the center portion of the stepper motor moves towards that energized coil, and then you release it and then energize the next side, so it keeps on moving in a clockwise or counterclockwise direction, depending on which way you're stepping, I guess. There's an order to it to get the direction. Okay, so let's plug in this 12 volt 1 amp power supply and see if it can handle all these motors at the same time. Well, those two are working. These guys are not. Interesting. Okay, what if we unplug these two, see if those two are working. This one's having a bit of a hard time. Let's see if I swap it around and see if that does. Pin didn't make a connection. Alright, what if I slow this down maybe a little bit? Maybe go to 550. Maybe it'll give it more torque, because I think we sacrifice a bit of torque when we go so fast. Alright, let's go COM port 4, upload. Seems this one is having a bit of stickiness. could slow this down even more and see if that helps. But I think it's just maybe the rails. Well, that helps. Definitely more, gave it more torque. Yeah, it helps if it's not resting on the table, because that adds even more torque. Wonder if orientation is definitely a factor as well. Because it's probably, if it's not oriented perfectly, probably has a hard time on the sliders sometimes. Or we can even go slower to up the torque even further, so we don't have any issues. Because we're going to have to move these things on there, so I think these were originally at 800 microseconds. I changed them all the way down to 450 just to get more speed. You can see that they're going slower. They definitely have more torque though. So put it on its side. Yeah. Definitely more torque. Okay, let's try adding these other steppers at the same time. I wish I had these 4-pin connectors. Oh, interesting. This one's not performing anymore. We do have 3 moving now. Well, this one's still moving. Still have 3. Once I add the 4th though, I wonder what's going on. As soon as I add the 4th, it seems that one wants to stop working. Interesting. So we'll have to figure that out. That's very odd. All 4 should be working because all the signals are being sent to each motor driver. So we'll have to see how that goes. We'll also have to test if this this guy can carry the load of this. I hope it can. We'll likely mount it on top there. So yeah, we have to do some testing here. I'll switch the view because we no longer need this. We've kind of verified that that all works. Yeah, we could up this microsecond delay to get even more torque. But for now, I think we're okay. Yeah, just reading some of these comments. Yeah, I don't think they're absolutely right in some of the cases. But yeah, we'll just transition our view here. Get this out of the way for a moment. And we're gonna have to figure out a way to mount these to these. And I may have to get a beefier power supply. We'll see. I don't know the reason why they're not all four of them are going at the same time. It seems that only three can. Yeah, we will have to see. But for now, let's do some mounting. Probably have to do some drilling. So many ads. So it's probably a good idea to get the wires moving, or sorry, the wires mounted the same way. And if there's stuff sticking out like this, we can probably just chop that off. With tin, actually, it's nice where you can actually just wiggle it back and forth and it should snap off. All right. I guess what I can do for testing is raise this up a little bit with some rubber feet so that this portion is not touching the surface at all. It's not rubbing or anything. I will just do that while we're testing. Well, I have more felt pads than rubber pads, so we'll just use felt. There we go. One thing we'll have to note too is that this tray can't run into the bottom tray, so we'll definitely have to make note of that. That it's kind of a ways away from it. And this will also have to slide all the way over here without touching anything like these. So I'm gonna probably trim those down. Little plastic bits that are sticking out. Either way, this has to get removed, so take care of that. Put on some safety glasses just in case. Woo! Almost lost that board there. Whoops. So we'll just wobble that back and forth. Might have to get a bigger set of pliers. Oh, it seems to be doing okay. There we go. That's snapped off now. I'll probably use the Dremel tool to file that down a little bit. So if you have your speakers on high, definitely turn them down, because we're going to be using this loud instrument here. That's better. Okay, I think I found the place where I want to mount it as well. I'll try to use this mounting hole here and a hole down there. And if that works, we'll probably get rid of this mounting tab up here, because we won't need it, and it'll just get in the way probably. Okay, what we need is a bit of hardware. And we're going to need a standoff. So, got a whole bunch of miscellaneous hardware here. That seems like it'll work. I just have to drill a big enough hole on that side for this to go through. Ideally, we'll just thread it into that metal, but we'll see how it goes. And then we'll have to figure out a way to get ourselves a standoff. So I was thinking about maybe hacking these drywall anchors I think I have more in the back to work as a standoff. We'll see how it goes. Yeah, I think I'll run to the back for a quick second here and go check if we have some more drywall anchors that might work for us. Excellent. I found some drywall anchors that should work for us. Just need to cut them down. Oh yeah, they're pretty big. I might have to use the Dremel tool on this bolt because it needs a bit of TLC. The threads are kind of messed up, so I want to shave this down a little bit. Watch your ears. Better. Still pretty hot. Yeah, I guess if you're just tuning in and you want to watch this at a later date, you definitely can. I guess that was one question that was on the Synthium community that. Oh, this is a bit loud. Sorry. But if you missed the live hack, yeah, you can definitely watch it at a later date. Okay. Sorry about that. I had to take care of something there. So we have our bolt. We need to likely drill a hole in this thing so this bolt can fit in. And then we want to have a standoff for this thing, which I'm making out of a drywall anchor. It won't have to be too big. I think I'll just cut it off here and then shave it down as needed. We'll have to count for the standoff when we figure out where we want to drill the mounting hole. Yeah, this will definitely have to go lower. I was thinking we might be able to cut on one side lower and one side keep it high so it can kind of nestle in the bottom of this little area. We'll see how that goes. Give it a shot. Yeah, that seems like it'll work. Okay, let's see if this is enough clearance. Yeah, that's definitely enough clearance. It can go down a little further. So we can trim a little bit here. Trim a little bit here. Let's skip that. There we go. Back to the music. Okay, let's see if that dropped it down some. Yep. Still a good amount of clearance. So we can trim that down even further, I guess. Let's do some more trimming. Yeah, we'll try that. If we need to trim further, we can. Okay, so we'll get the drill, drill that out so we can, might even tap it. I think this is a 1032, I believe. Test that. We can tap it, possibly, and make it thread right into there. We got a nice tap and die set. These threads match up. Yep. That's the one, 1032. So while we're here, we'll try to fix the threads on this guy because it's been cut down. Ooh, whoops. Careful. This actually has a Robertson head on it, so get a Robertson screwdriver and make my life easier. Go. That'll work. Now we need to drill the hole and then we'll tap it with the 1032 tap. Now I just need to figure out what drill size you need for a 1032 hole. So it says a number 21 drill bit. So 1032, 5/32 inch. Okay. There we go, 5/32. Okay, let's drill that. setting. Okay. I'm trying not to keep this too close to the microphone. This will probably be loud. So we'll put this on top of something so we don't drill into the counter. I would not want to do that. I'm gonna go grab a scrap piece of wood from the back. I'll be right back. Okay, here we go. Wow. It's deeper than I expected. Get rid of all that. There we go. We're through. This metal's fairly soft, so it'll be easy to tap. Usually when you're tapping some hard metal like stainless steel or something like that, you can kind of go a quarter turn and pull back, quarter turn, cut, and then pull back, and that allows you to get some good cutting of the threads in there. With this soft metal, you can just so easily go through there. Okay, get this tap out of here. like having all these metal shavings on my bench, especially when you're working with electronics. Not such a good idea. Let's just test this. Yeah, there we go. Threads in there perfectly. Okay. So let's get rid of some of this garbage here. Next, let's mount this guy on there. Okay, here's the spacer. Just thread these together. We might even have to bring the spacer down a little bit more. We'll see. Alright. It's on there okay. I have a feeling it's gonna twist on us. So we may have to put like a rubber washer or something on there. Look at the clearance. You can see that it's at an angle, it's tilting a little bit. So we can bend the metal a little bit to compensate, to make it kind of straight. Could go a little more, I guess, but seems pretty decent. I think that's more than enough clearance at the moment. We could probably whittle that spacer down a little bit more to get less clearance, so you get smaller form factor. But let's try this out. We'll plug these into here. See if they can both move at the same time. Of course, I don't have the 12 volts plugged in yet, so none of the motors will operate until I do that. Alright, we're all plugged in. Skip some more ads. Okay, moment of truth. Okay, here we go. Let's plug in the 12 volts, see what happens. See if it has enough torque to carry that other assembly. Yeah, it's looking good. So yeah, we'll definitely have to cut that off because it's sticking out so far. But yeah, I'm pleasantly surprised. That works out pretty good. Right on. Okay, I'll have to put some little cushions on the bottom of this one, and we'll mount this one to that. Make it work kind of like this. We may have to extend some wires, we'll see. Actually, I'll make this go all the way out so we can see where it stops. Okay. for now. So this one is going to definitely overlap with this one if we mounted it right here. So we'll likely have to shift it over, maybe drill a hole in there. Remember, this is actually going to be like this. So yeah, if we mounted it back further, this is definitely going to overshoot the corner of where, I guess, the travel of the boxers. It actually looks like this needs to be out a little more too, so that the boxer can reach this corner here. So that's looking okay. I don't think I'll be able to actually mount that center pin that I was hoping to, because of how far this will travel. And yeah, I'm gonna have to be careful so it doesn't hit this one. I may end up having to mount it like this. I hadn't really thought about that. And then have the end of the travel kind of butt up against the other one. Yeah, I think that will be our best bet, is to mount it in that configuration. Just like that. We'll have to limit the end of travel on this side with a limit switch or something to let us know exactly how far we can go. And then this could be the maximum. We'll definitely have to cut that off so it doesn't run into the other one. But I think that's going to be our best bet. We could still use this as one of the mounting tabs. I just hope in the end that all this has enough torque to move these guys nice and smooth. So there's a little bit of weight there, plus the mounting plate. It's going to have a little bit of weight too. We might be able to figure out a way to not use these mounting plates, but just use these and have the servos reside on or mount to these plates. Maybe not. It's going to be tricky. I do like the amount of clearance we have. It's a good thing. So the idea is that this hole here will mount to the XY axis here. Or so I should say, one of the axes. I don't know if it's X or Y at this point, but that hole will mount onto there. a good idea where I should mount it on this guy. Found a spot. Should work. Then I'll have to find a plastic screw that can mate with that. Well, that's rather long actually, so maybe we won't. We'll actually mount to a plate or something. We'll see. Let's see here. I feel like we may not have to trim these plates. This plate, maybe might run into down here. It is a bit big. I might even be able to split it, one of these in half. Yeah, servo motor doesn't fit under there with that plate, so we would definitely need a little bit more clearance. We could shave this down like I was talking about. We don't have to shave it all the way down, though definitely a little bit. Unless we found a material that was thinner than the acrylic here. I apologize if you can't see what I'm showing you. I think I nabbed this up high enough. So if you didn't see what I was saying, that with this guy mounted at that height, I guess we could always increase the height on this and where it mounts. It's a little bit tricky to get the servo motor mounted to this acrylic plate and still have clearance for it to move back and forth. I think actually in the end I will leave these felt pads on here because the whole game may end up resting on these. I never thought of it. It's actually probably a good plan. These are pretty solid. Okay, so we'll cut away this one, this piece here, and we'll start working on the next XY system. I think that it's probably a good idea to actually get one XY system working and then worry about the next one after. See if the theory works first. I don't know. Do we do it? Do we do a bunch of tests first? Make sure it all works perfectly before we put this one all together? It may be a good idea. I think that's probably a good idea to get that all figured out first. And then we will need some way to prevent this from pivoting. Actually, if we lowered the clearance down a little bit, we could actually use there's a little tab down here, and we could lock it into place onto this guy. Actually, even a little bit of hot glue should make that work. Yeah, what we'll do is we'll shave down our spacer a little bit because we could get a bit more clearance out of there. And then we'll do some hot gluing, and then this thing shouldn't move whatsoever. I want to be done by 9 tonight, so we'll see how it goes. I don't think I'll get to the software tonight. The hardware portion of this hack is pretty intensive, so we will have to likely continue on another day with the software side. So we'll undo that, trim down our makeshift spacer, We'll put it back together, see how it goes. Trim it a little bit more. I think that'll be good. Why am I using a flat blade screwdriver when I can just use this Robertson? And for those of you from other countries, we Canadians use this this weird kind of screwdriver called a Robertson. It has a square end on it, because we're squares here in Canada, and don't you forget it. Okay, I'm going to bend that down a little bit because it's sticking up. And I believe that will be good after we stick a little bit of hot glue in there. I forgot we need to trim that, so maybe I'll wait for the hot glue to set. Oh, don't touch hot glue when it's hot. Whoops. If you do, just rub your fingers together really quick. My bad. Did not mean to do that. Well, I noticed something that has been unfortunate. The one side is rising up a little higher than the other side. So what I can do is just use the hot air rework station, melt some hot glue here, and then drop this side down a little further. So we'll transition here to this side so you can see over here. Get rid of this. Use the hot air rework station on a low setting here. And we'll hold that down for a little while. So you can actually use these XY tables just like this, just like with these two little drives, and you can build a drawing robot. You can build a 3D printer, a laser cutter. All those technologies use the same sort of assembly, which is what they call an XY table, where you can get XY movement. So basically this piece here can make, this little pick, let's say, like do a pattern anywhere, like in the range that it can reach. So say it can do a square like this, it can do any sort of pattern inside of there, circles, squares, triangles, dog shaped, whatever you want. That's the power of an XY stepper table like this. And there's some open source hardware or software out there that allows you to make it all work. Okay, so while we're here, let's turn off the hot air workstation and let's take this piece off because we do not need it and it's in the way. I'm actually a little bit scared of torquing this too much because this rail right here needs to be nice and smooth. So if I bend it out of shape, let's do something a little easier. Let's use the jaws of a large pair of needle nose pliers to cut that right off instead of wiggling it back and forth. It's not actually doing as good a job as I hope, so we're gonna instead go to the Dremel. And the Dremel will take care of that rather quickly. Okay, so if your speakers are on high, turn them down lower at this point because it's going to be loud. There we go. The Dremel made short work of it. No, sorry, it's right here. Okay. So, yeah, like I was saying before, here I'll transition over to this other view. We're going to want to test this out in practice before we go through all the trouble of putting this other one together and then having things fail. So this is going to be definitely a tricky build. I don't know if it's going to work or not. We will see. So it's going to be a matter of just testing things out. I might pull these guys off because they're a little bit annoying right now. See if that, it looks like they're modular, so they should, in theory, pop off. There we go. There's one. So, got the ring out of there. So this is much easier to work with now. Don't need those. I'll put these on the bottom of this for now. So I can get these out of the way. We'll probably need the tap and die set later on. Won't worry about it now. We'll charge the drill up. Just looking at our other drill here, it seems the battery might be defective on it. Okay, well, get this out of here. So the parts we're kind of worried about right now are this plate, which goes on this side here. That's what these guys mount to, and this plate nicely covers up these holes in here. No matter where it's at, it's all covered up. So, worried about this guy. Well, I'll put this guy over here for now. This is the screw that, no, that doesn't work. This is the screw that'll likely mount this assembly, which will be over like this. We'll likely need a hole drilled right through this pot metal at some point. Maybe even this hole right here, actually. We'll see how it goes. So we'll need that screw, put that in a safe place. I guess all the other pieces for the other robot will just stick over on this side here, so we don't have to worry about them for now. Out of our way. Don't need to worry about one robot right now. It's nice to kind of simplify a little bit, so we don't have a whole bunch of parts all over the place while we're trying to work. So the idea is that these two servos should mount on this plate, and this plate will have holes in it, which will go up to the top plate, and these will have arms on them that activate the punches. So we will have to test to see if these have enough torque to do that kind of thing, which I'm pretty certain will be a no-brainer. I think they'll work for sure. Get some more stuff out of here. We might even have to make some cuts on, or else we can just cut this metal. It's always a possibility. Make this kind of fit lower. might do that right away actually, because this is getting in the way and bothering me. Actually, to line it up better, this will actually have to overlap the side here. Well, our music stopped. Let's get that back going. Alright. Yeah, we have to figure out how to get our full range of motion. Which will be the best place to have this. You have to remember that this will be in the middle. I guess this portion, I should say, will be mounted onto here. So it still has a little bit of travel on that side that we have to account for. Actually, I think a 1032 screw will do well on there. And I think I should be able to snap this in the middle and have more than enough for both of these. I think I'll do that so I can start forming these plates. I'll split this in the middle. I'll show you guys the tried and true method that somebody had taught me for snapping acrylic. Get some how long this is. Let's see if it's in inches. Of course, it's about 5 inches. So we want to snap this thing just over 2.5 inches. So draw ourselves a nice little line. Usually I do like 3 dots, 3 or 4 dots, and it makes it a lot easier to line up the ruler. There we go. You can keep your ruler there, hold on to it with your fingers, bring this to the edge so you're not cutting on your surface. Lock your knife in place and score that acrylic as deep as you can. Oops. right along the edge of the ruler. You'll want to do this like, I don't know, 5, 6, 7 times. It's nice to have a metal ruler so you don't actually cut into it with this X-Acto knife. And once your score is there, grab yourself a pair of gloves. Because you don't want the acrylic to break in your hands because it could cut you. It's very sharp stuff. Get your gloves on and then hold it right along the edge of a countertop or table, right where you made that score mark. I'll see if I can do it left-handed, I guess, so you guys can see better. Just line that up as good as we can. And then all you have to do is put a whole bunch of weight on the other side, and it should snap cleanly. There we go. Pretty clean break right there. So I'm going to go to the back and just use our power tools to clean up, kind of round those edges so I'm not dealing with sharp edges. So I'll be right back in a moment. I'll clean these up at the same time. Actually, I'll just clamp them together, just clean them right up with our sander. Alright, so take a break for 2 minutes and I'll be back. those corners so we don't cut ourselves or poke ourselves with anything. Alright, I think I'll just probably use a file to touch that up a little bit. And we'll be on our way. Probably should have my safety glasses on at the moment, so there's no plastic bits that fly in my eyes. Yeah, I like working with acrylic, but it is kind of a pain sometimes when to round all the corners and get rid of all the sharp bits. But otherwise, it's fun to use, easy to use, nice and sturdy. Okay, so the idea was to make a smaller plate that can hook up to these plates on the bottom side, and so that we can put our servo motors on them. And the servo motors will, I need to grab some of the some arms, but the servo motors will activate these little pieces down here, and they'll make the robot punch. Punch, 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 punch. So we will have to find a way to, we'll probably have to drill some holes, maybe use the Dremel tool to open them up this wide, and then get a plastic screw to mount into here. Since we were previously Easy Robot, we have a bunch of plastic screws around that I can use, which is handy. So I'm gonna try to get this to fit right against here nicely. We'll see how it goes. Do my best. So we should try to get everything lined up center. What I will do, I think, is drill a hole in the center of this, put a plastic screw in there, and then do a little bit of tracing around these edges over here to be able to cut out the circles properly. Alright, let's find the center. So 96 centimeters. So that is divided by 2. So 48? Yeah, 48. And then this way, it is 64. So that's an easy 32. Well, I kind of smeared the marker, but I can always use a pick, a dental pick, to make a little dot in the center there. Well, that'll make it easy for our drill. Don't know why I keep on taking my safety glasses off, because I keep on needing them. Okay. Let's get our drill that hole. I think I have a bunch of plastic screws in my little miscellaneous bin there, so we'll try those out. So we need to be a little bigger. Yeah, perfect, that'll work. So, I'll have to get a smaller drill bit so I don't make the hole too large. I think 1/8 will do it. And then let's use our little drill block here. When drilling acrylic, it's always good to have exit material, such as a piece of wood like this, or else you may crack the acrylic. It's pretty easy to do. Okay, let's see if this screw goes through. Yep, perfect. And then we need a Phillips screwdriver. Wow. It's handy when you need it, but it gets in the way after. Okay, so let's see if we can get that lined up with the toes of the robot. It's kind of a weird shape, but as long as I get it lined up with these two toes, then we'll be fine. Okay, right there. And now we need to trace with our marker where these holes should be. It's hard to get this marker in there, so maybe I'll just use the scratching method. score it. Alright, it's scored up nice and good. Take the screw out. There we go. I don't know if you can see that from here, but we got some score marks right here and right here. So we'll be able to make a circle now. I wonder if I have something actually that's maybe that shape, so I can draw a better circle around it. It's kind of an odd size. I have some washers, but those are too big. This is a little bit too small. The head of a screw. Aha. I think the speaker will be perfect. Yeah, an Iotani speaker works out really well for the circular shape. Okay, this will help me finish off the rest of the marking the circle. Actually, get a better. So I don't think we'll have a drill bit that's large enough for this hole. So I think we're gonna have to rough it in with a Dremel tool. Alright, there we go. So I think that I'll drill a small hole at first in the center of each of those. Get it started. Use our biggest drill bit. Drill the rest, and then I'll use the Dremel to kind of cut it larger and larger and larger. I think that'll be the fastest way to do it. So we'll need our drilling block again. Find the center of each of these. Actually doesn't really matter too much if we get dead on the center or not, so because we'll be roughing it. This may give us a little trouble because it's such a big bit. No, not bad. 2 decent sized holes, and now ream those out with the Dremel. Okay, make a whole bunch of noise again. Watch your ears. Well, not exactly perfect circles, but I roughed in there pretty good. Let's just see if it fits now. Ah! Probably not a good idea to drop acrylic. Could break. Could use a little bit more on the inside. There we go. Okay. There we go. We're mounted on. Decent. Shakes a little bit. I think that we could get a plastic screw that is a little bit wider. This one isn't holding perfectly, so we might have to widen that hole if we do get a wider screw. That's funny, it's a Robertson. Yeah, this one is cool, man. I think it's a little bit too big. almost there. I'll have to look in my other miscellaneous bin, because all I'm seeing is the same size screws in here. Yeah, it's the same size. Well, it looks like this, I think this is for an outlet, this an electrical outlet. It seems to be, I think it'll work pretty well. Alright, so we'll widen that screw hole a little tiny bit. And that was 1/8 that we used. So we'll just use the 1/8 bit and ream this hole out a little tiny bit by just going around in a circle. Do it on the other side. There we go. Okay. There, that's better. It's on there good now. Okay, so let's mount the robot. First you fit the toes in to this plastic piece, and then the heels. Okay, so that's what we're dealing with there. They're the little blue pieces are sunk down a little bit. So when we create our servo horns, they're gonna have to have like a plunger bit that goes down. So it's gonna have to go out and go down. So servo hopefully fit kind of like that on there. Let's start up the music again. Okay, and that will, this plate will likely bolt on to this center portion. So this portion right here of the, let's call it the x-axis. And it will have to have room for the servo motors as well. So I think we should probably create this piece first with the servos, so we can kind of see where our clearance is going to be. I think it would probably be best to like have a hook shaped activator that can go down and activate these punches. Or I can drill a bolt into, or like a screw into each of these and extend them, and then the servo could like pull or push it, I guess. I should measure how much action we need here. Flat blade will be the best here. Put a mark on the screwdriver. See if that's proper length here. Yeah, it's pretty close. This doesn't need to be pushed all the way in to activate the full punch. Well, actually, we may have to, because it has to raise up high enough to hit him in the face. So let's see here. Okay, bottom's out there. So I think it's gonna have to go fairly far, actually. About a centimeter of travel or more. Yeah, about a centimeter. So it's interesting turning rotary motion into linear motion. We could do something like I think they call it a rack and pinion, where you have kind of a linear piece that has a whole bunch of gears, gear teeth on it. It's just a long linear piece, and then you have the rack, I guess. No, wait, the pinion. Maybe I should just look this up. We have a computer here that can help us out. Let's see, rack and pinion. I think the rack is the the rack is the long part, and then the pinion is the piece, the gear that actually makes it move. So the pinion would be on the gear side, and it would help the piece move up and down. That would probably be ideal in this kind of scenario. What I want to do though is like, I'd like to see how those other guys did it with their hack. I'll transition here so you can see. We don't need this. Full screen this. Rock 'em, sock 'em. Robots. Hack. Oh, interesting. I'm already on YouTube. Where did I save that? I think I might have saved it in my other browser. Maybe not. Oh yeah, Texas Instruments. It was for a contest. This is the one. Okay, how did they do this part? It looks like they drilled a screw in and just extended it, and then just used the servos to push down on them. So this is what I'm kind of modeling my system after. Except for the XY axis. This was a pretty smart way with doing it with servos. If my way fails with the XY gantry system, then I'll move on to the servo system like that. So I think I also have some PCBs, like they use the PCB material here. So I also have the PCB material to do that. Yeah, I'm surprised. So, oh, I think I see what they did. Did they cut holes, slats? No, it doesn't look like it. It just looks like a circular hole. And this was an interesting system here with nylocks, a few washers, and it mounts, I think, directly into the center plate, or the center post, I should say, of these guys. Oh no, I guess, sorry, it attaches directly to the plexiglass. And I'm guessing that they probably like glued this plastic against the plexiglass here, or acrylic I should say. Interesting way of doing it. So I may copy this method where they extended some screws out of there and then they just pushed them down with the servo horn. Looks like they were a little ways away with their servos. I could kind of do something similar. And here, I'll switch the view here. So I could offset the servo kind of like this. Oops, sorry. Kind of like that. So the servo horn is pressing down there. Do the exact opposite on this side. Or something like this. So we would just have to extend these guys by sticking a plastic screw in there. I think I have just the ones. Come to think of it, we definitely want a larger head on the screws. The ones I'm thinking of have a small head on them. So, yeah, I might have to find some different ones. They have to be long and have a decent sized head on them. So, I think that like wood screws might work. They have a flat head. They're fairly long. I'll go see what I can find in the back. Or drywall screws. I think those would fit as well. So we'll see what we can find. I'll be back. Alright, I think I found the perfect screws. They're 1 inch long. I think these are like a drywall screw because I got a fine thread on them. So, and they got a large head, so that works out well for the servos. We have to pop this guy off here. There we go. Yeah, I'll have to go in pretty deep. Oh, nice. So the screws can fit right through here, so I can put them in. I can install them right here. So that'll be handy. We will need to make a small incision. Smaller incision, there we go. Oh, that's too small. I think we'll go with 3 30-seconds. Yeah, I think that'll be perfect. Okay, where my safety glasses at? There we are. Okay, we're going to try to drill a straight hole into these guys. Try to get it centered as best I can. This plastic is thick. It's gonna be a little bit trickier than I thought. So we're gonna have to drill down enough that we can get a good solid chunk of this in there. Yeah, we're gonna have to give it the old one too. Just give it all we got. Oh man, I think this plastic is like Teflon. It's definitely drilling really weird. The bit I have might not be very sharp either. Yeah, it does look pretty dull actually. Might have to go a size smaller. Bit's probably sharper, yeah. Oh yeah, that's much better. Yeah, we're getting there. Whoa. We drilled right through onto the other side. Okay. Let's see what we can do here. It's pretty difficult actually to hold on to this and screw it in, so let's use some pliers to make our job easier. Okay, that went in there pretty good. Let's see how far it sticks out. Oh yeah. Oh, that's the trouble. I can't get this in there perfectly because the toes have to go in first. So that's a little bit of a conundrum. So let's get that screw out of there. At least we cut some threads first. Put him back in place. Toes first. There we go. And then screw this screw back in, but maybe difficult to hold on to that while we screw that in. Yeah, it's gonna be tricky. Ugh. Oh man. I think we're just gonna have to try and screw it in without holding on to it. I could use a larger screwdriver. Use a number 2 instead of a number 1. I don't want to break this plastic. Okay, let's see where this is at. It's definitely going to have to go down about 1/2 centimeter. I don't know if you can see that, to be lined up kind of with the center of this. So we're going to have to use the pliers to hold it together. Ugh, what an awkward scenario. Well, I'm gonna get the screw out of there for now, so we can drill a hole in the other post. Maybe we can kind of cut some threads like this. Gonna make it a lot easier to thread in. Yeah, you can feel the plastic bending, and that's not good. Okay, so let's drill the other hole in there. And then we'll try to figure out a way to make this work. Oh man, we're running out of time here. I want to be done at 9. So we'll see if we can get as far as testing out these servos with pushing down on the arms. We'll see how that goes. First we need to get it all mounted together. Kind of score this a little bit, make ourselves a little center hole to guide the drill bit. Well, we're a little off center. Check that a bit. worked out nicely actually. Let's go a little bit deeper. There we go. Okay, then let's cut some threads in here. Going on here. Okay. Let's mount this guy and then get the screws put into his feet. Oops. Get both toes in there. There we go. We have to figure out a way to hold on to these while we put the screws in. Which is going to be a bit of a challenge. I could just jam the pliers in there, see if they can hold it that way. That could work actually. Okay, let's see if we can do this with okay, I think that is likely enough. That was pretty good. Just need to do the same on the other side. That's good. Sorry. There you go. You can probably see that better now. Okay, so what we need to do is hot glue these servo motors on here, get the servo horn lined up. Actually, I should probably put servo horns on now. probably go a little bit further down. The other one made it a little bit further. No, I think that's it. That was getting stuck. That's not good. See if I can bend it a little bit. Okay, that's good. Let's get these servos in order. Whew. Servo screws too. Plug in our servo calibrator.
This is the ECP servo and RGB eyes test check. Have fun.
Snip off half of these guys. We don't need both sides, just one side. Actually, I should line up and see which side we'll need. I think that'll work out better. So at 90, it'll be like that. Actually, let's have it pressing down a little bit. Oh. Like that. No. We one tooth up. There we go. Just like that. Okay, let's stick a screw in there and hot glue the servo onto here. Okay, I'll hot glue it on like that. Okay, we'll get this other servo prepped. Go like that, or we can go like that. Cut that back piece off. Whoops. Definitely shot around the room. Didn't mean to do that. Put that screw in there. And then we'll hot glue it on like so. Okay, I think the easiest thing was would actually be, don't need this calibration jig anymore, but to unscrew this. Mount this guy on that platform. Like so. Put this back on. Make sure it's going the right way. There we go. Alright, cool. It moves around nicely. Servos are on there. Let's run the servo wires to the side here. We'll go up to easy D. And we'll see how it punches. D0, D1. Okay, let's load up Easy Builder. reposition this so you guys can see it better. Okay. Let's connect to the EZB. Let's add some servos. Servo, horizontal. Let's do the min and max. D0. Same thing for D1. Save that. Center those. Oh, that went to 45 for some reason. Oh, that's why. Okay. Okay, let's see what happens. Alright, let's see how far the servo can go. Okay, the servo is hitting the plastic there, so it definitely needs to be positioned a little bit back more. Let's see this one here. Okay. That one's actually positioned pretty decently. So max it can go is 39. It's also bottoming out on the plastic there. So 77 to 39. Oh, sorry. So this arm will have to be, I guess the servo for this arm will have to be positioned a little bit differently. But this one, let's see if we can get full extension. Not quite, because it can go up to there. So I'll need to trim. Or I have an idea. We can unscrew the screws a little bit, if you know what I'm saying. The screws come out further. I wonder if I can do this on the fly like this, if this will work. Actually, I'll just take this off for a second. So these can be sitting taller than I thought they would have to. go. Oh, that's a... There we go. Okay, let's see how that goes. Ah, there we go. Can go all the way to 40 and get all the way up there. So let's make a little script here. Oh, sorry. I'll transition. Oh, not that scene. We want a different scene here. We want this scene here. We'll write a little script that goes servo D1, go, the resting position is like 112, let's say, and then sleep for a second, and then go to, I think it was like 40. Let's just do 50 for now. Servo D1, go to 50, sleep, 1 second, and let's do a go to statement. Oops. I think I need to disable IntelliSense. Let's go start. Okay, so let's see how low we can go. Yeah, I think 48 is probably good. Or 46. And that will be, actually, go servo speed. I think it's 0 is the fastest. Alright, he's punching. Well, that's one step complete. That's yeah, step in the right direction. So we got him punching. with one arm. I'll have to adjust the other arm. I'll just have to adjust the servo position a little bit. It'll be fine. So yeah, we got full extension of the punch. Yeah, so this one is, the servo actually popped off because it hit this side and pressured itself right off. So that will have to be adjusted. To get rid of this hot glue, we'll just spray a little bit of rubbing alcohol, isopropyl alcohol, and that comes right off of there. And so we'll just put some more hot glue on it and adjust that position, and it should be good. I think it'll be around the same values, 112 and 50 likely. Actually, let's just hot glue it now while we're here. Why not? Hold that in place and have a look. Oh yeah, definitely needs to be pushed back a little more. Yeah, it's definitely gonna need a bit of tweaking to figure out the perfect location for that. And the screw is kind of getting held up on the yellow plastic, so I'm gonna have to adjust that a little bit as well. So yeah, we'll take care of that next time we do this hack. There. Okay, I think that's going to be it for tonight, guys and gals, if you're watching. I assume that it's mostly a male predominant crowd, but definitely be awesome to have some ladies joining us. There aren't too many ladies in the field of robotics, it seems. It'd be awesome if there were more. Okay, but the other side seems to be doing great. It's in the perfect position. Alright, time to call it quits. Okay, I'm happy where we're at. We do need to do a bit more with this, but I feel like since it slides so nicely on here, I think it'll be good. We'll get that mounted underneath, get him moving around. Let's actually kind of test the clearance here. See if it'll be all right. Yeah, I think it will be good. This will drop down a little tiny bit, and this will be straightened out. I think we'll have enough clearance. Won't have to do too much modifying to make it happen, which is excellent. And we will have to figure out why this thing wasn't making all of them at once work, so we'll have to figure that out. I think that the next hurdles will be seeing if this has enough torque to move this guy around. And then, yeah, if that works, if this works, move this guy around, we can start working on the secondary side. And oh darn. I think I sprayed too much alcohol spray and I pushed the servo right off of there. It's sad because it was in the perfect position. Well, we'll have to figure that out next time as well. Put that back in the right place. But we know it works, so that's awesome. Maybe not as fast as I hoped it would be, but works still does work. All right, let's switch this to our first scene. So we have a few more challenges to overcome on the hardware side, but I think we're almost there. I think the proof of concept is almost there. Then we have to work on the red robot side. Excuse me. Should be a lot faster. And yeah, and then we'll be on to the software side. See if we can get these robots fighting automatically against each other and also against a user. So I'm gonna check the chat one last time. No, it doesn't look like we got any more chats, so I'll sign off. Thanks for joining me in this hack, and I hope you enjoyed it, and we'll see you next time. Have a great, I guess it's not a weekend, so have a great week. See you later.